Thanks, Elizabeth. Thanks for the introduction. As you can see, my background behind me is different this week because I'm at a friend's house in Whitby, up north, because I went on a pilgrimage to Lindisfarne yesterday. And so I think well, I'm on the same computer, so hopefully it should be the same quality as last week. Now, this week, it's going to be quite a change compared to what I talked about last week. It's going to be much more towards geometry and cosmology. And I think I'll go into more of the interpretation of what I show you this week, next week. So the first talk and today's talk, I'll link the two of them together more so next week. But this week, I'm going to show a lot of this material relating to really the diagram that was devised, or you could say rediscovered, by John Michell in 1971, a really remarkable discovery, which hasn't really become that widely recognized for some reason, probably or possibly because John Michell was a bit on the fringes in terms of how people perceived him. But the thing really that got me interested, as you'll see when I start showing the slides, is that it appears that his diagram was used in the design of various English Gothic cathedrals. And the main one that I'll be talking about in the city of Wells, where I usually am, where I live, I'll talk about that a bit more next week. It's at a very similar latitude to Stonehenge, which also comes into John Michell's work, but more about that next week. Now, I think I'll go straight on to the slides. So I'll share my screen. Right, Elizabeth, Julie, I'm assuming.
All fine.
Yeah, yes, clear.
Great, okay. So I think I started with this slide with last week's talk, but what you're looking at is now really more so what we're going to be focusing on today. Now, of course, last week's talk really focused on the ascent of the soul, and really you could say the perennial storyline of the ascent of the soul. And the way in which it showed itself in 12th century Christianity, which, as you can see, was very much the ascent to wisdom as understood through the study of the 7 liberal arts and wisdom as an enthroned female who also is symbolically a ladder, who in Christianity is very much associated with the Virgin Mary. Right, so let's proceed. Now, I'll begin from where I finished last week, which was talking about the idea of ascent, or the journey between heaven and earth, or earth back up to heaven, relating to the coronation chair. Now, the monarch, or the king symbolically, is, I suppose you could say, an image of the microcosm, the one who actually brings heaven and earth into relationship. In my book that's soon to be published, Cosmos in Stone, I show the Chinese pictogram for the word king. And this is something that René Guénon focuses on, where he talks about how this pictogram for the king has 3 horizontal strokes, which are joined together by 1 vertical stroke. And so it can be understood as heaven, man, earth, joined together by this vertical axis. And so this ladder between the worlds is associated with the king. And what I talked about last week with the English coronation chair is that you have the cuboid stone of destiny below the seat, which is, you could say, either the cuboid of earth or the foundation stone at the center of the earth. And then you have the circular crown placed on the head of the monarch. Now, the foundation stone is also known as Jacob's pillow. And so the ladder, Jacob's ladder, where angels descend and ascend, you could say, is the body of the monarch. Now, I also pointed out how this can be, I suppose, the coordinates of this idea can be plotted out as a square-based pyramid, where you have the square of earth, which is like the cosmati pavement that the coronation chair sits on, and then the unity of the crown as the corner up above. Now, the red triangle that's highlighted inside that pyramid, that's really what we're going to be focusing on in this cosmological diagram. rediscovered by John Michel back in the early 1970s. But before we do that, I want to show you a short quote from a Hermetic dialogue known as the Asclepius. Now, this is significant to our storyline of medieval Christianity because Asclepius, the dialogue, was translated into Latin at an early stage. So it was commented upon by various Christian theologians, mostly favorably. And that was because parts of it very clearly really concorded with certain Christian ways of looking at things. And you'll see that very much from the quote I'm going to show you here. Man and man alone of all beings that have soul is of twofold nature. Of the two parts of which he is composed, the one is single and undivided. This part is incorporeal and eternal, and we call it that which is formed in the likeness of God. The other part of man is fourfold and material. So as you can probably see, this is really, well, it's virtually the same as the dual nature of Christ, which is of course an image of the human as both divine and human at the same time. And you can actually, I suppose, see this in terms, again, of the pyramid form with its square, earthly, fourfold material base and its singular crown. Now, I also mentioned last week that this type of pyramid, its square base can be looked upon as having a measurement of 11 units. And then therefore that means that the red dotted line pyramid triangle also has that same measurement of 11 along its baseline. Now the height, and this is really where we link with some of what we're looking at last week, the height is 7. And so you have this idea of this movement between these two aspects of soul, or these two worlds, from the square of earth up to the heavenly realm, consists of 7 steps. And this, of course, just reflects very directly all of what I was talking about last week. So you can see how geometrically this is really a very appropriate form to be focusing upon with this idea of an ascent from the below to the above. So here we have that pyramid triangle, which is in red dotted line within the 3-dimensional pyramid form. And you can see it has its height of 7. You see down at the bottom here, there's the 11. I'll talk a bit more about this diagram as we go along. I'll gradually unfold it from the beginning. So we'll look at this in very gradual detail shortly. Now, this type of pyramid and the pyramid triangle that's its cross section is the same as the type of pyramid that is the Great Pyramid in Egypt, which is this the pyramid on the right in this image. This is an image I took, in fact, in the mid-90s when I was traveling around the Middle East. Back before the days of digital imagery. I quoted Hugh of St. Victor last week, a Platonist monk, and this is him talking about the lineage of knowledge in terms of how knowledge of geometry started and how it came through to the medieval world that he was living in. Egypt is the mother of the arts, and thence they came to Greece, and thence to Italy. Now this, in the medieval church, was the lineage. This was the understanding of the lineage. The idea that things started with Greece is a later idea. Now, I'm not entirely sure why Egypt was bumped out of the lineage. There's various, I think, suggestions as to why. But just to say, this is really the way to look at the medieval Christian understanding of the liberal arts, that they are beginning in Egypt. Traditionally, that's the starting place. That's where geometry is first discovered as well. And I'll show you a quote talking about that in a second. Now, the reason why there is this idea is because these medieval Christians are essentially looking back to the ancient world and quoting ancient authors. And so that's how this idea comes through. Now, here is an example of this idea. Pythagoras was told to go to Egypt to study geometry and cosmology by his teacher, Thales. And Iamblichus wrote about the life of Pythagoras, and this is a quote from his work. In Egypt, he frequented all the temples with the greatest diligence and most studious research, during which time he won the esteem and admiration of all the priests and prophets with whom he associated. He thus passed 22 years in the sanctuaries of temples studying astronomy and geometry and being initiated in no casual or superficial manner in all the mysteries of the gods. Now, perhaps it's being a geometry geek as I am, whenever I see numbers in older pieces of writing, I'm always interested as to whether they're actual literal facts or whether they're perhaps symbolic numbers or possibly both at the same time. Because the number 22 is very significant in relation to geometry and astronomy, as we'll see with what I'm going to show you as Jean-Michel's diagram. Now, geometrically, if you listened in your mathematics classes, you may remember that one way of talking about the relationship between a diameter and a circumference of a circle, which is 1 to pi, 1 to 3.14159265, it goes on and on and on. It's what's known as an irrational number. But the way in which it's described in rational terms, in the sense of there being a rational number for the diameter and a rational number for the circumference, is to divide the diameter into 7, and then you can say that the circumference will be virtually, but not quite, 22. And so you have 22 over 7 pi. That might be what you find familiar. 21 over 7 is the same as 3 to 1, but 22 over 7 is 3 1/7 to 1, if you see what I mean. Now, what I'm going to do is double this. I'm going to put extra dots halfway between all the dots that are already there, like so. So all I've done is doubled it, 14 as the diameter and 44 as the circumference. Now, the final thing I'm going to do is to just take into account a radius. So I'm going to halve that diameter, so we just have the radius, and then we can say that the circle with a radius of 7 has a circumference of 44. Now, I've been caught saying that in my sleep. My wife told me that I said that in my sleep once, so it's obviously this overriding obsession that I have with my work. A circle with a radius of 7 has a circumference of 44. Now, to begin with, this is you're looking up at the ceiling of one of the bell towers in the cathedral at Wells that we're going to be looking at in quite a lot of detail soon. Now, what you're looking at is a hole which the bell ropes would hang through, and someone I met recently whose parents were very much into bell ringing, she said that the fact it's that big, that it's probably about I don't know, about 3 or 4 feet in diameter, what you're looking at here. She said it would also be for the bells to actually be transported up to the bell tower, so that's why it's so large. Now, the thing I want you to look at are the foliate forms that are going around the circumference, so these here. Now, again, if you're a geometer who counts everything, you count them and you find that there's 44. So we see that this division of the circle into 44 is certainly being used in the cathedral. And it's not the most obvious division to use if you're using compasses and straight edge to divide a circle. 40 or 48 would be much more straightforward. But if you're using this particular division of the circle, then it can be useful if you have a piece of string of 7 units, and then you can draw your circle with your string of 7 units, and then you can wrap the string around the circumference 7 units at a time until you get 7 times 6, 42, and then add 2 more on. So this is a certain type of geometry. It's not the most straightforward geometry. So seeing this is quite interesting just to begin with. Now, this is an illumination associated with Hildegard of Bingen, Das Weltall, which means the universe, the world all, if you do a literal translation. Now, what I want to point out to you first off are the red stars, which are going in a vertical line. There's 6 of them, and then you can see the crescent moon below them. Now, at the center of the diagram is the Earth. And then you have this ascent through the planetary spheres, much like what we were looking at last week. The moon is, of course, the lowest sphere, and then you have Mercury and Venus, and then the large red star is the sun, and then Mars, Jupiter, Saturn beyond that. And this is how Hildegard describes this particular vision that she had. So we have this association of 7, of course, with the planetary spheres, and we've just been looking at it also as being the radius of the circle. Now, if you carry on counting and you count all of these yellow stars here, you'd see that there's 44 of them. So you have this 7 and 44 within this particular cosmological diagram. So in that sense, you can say that we have this direct association of the radius of 7, which moves from the center to the circumference, being associated with the 7 planetary spheres. Now, I want to show you one more quote before we go into the geometry. And this is from Isidore of Seville's encyclopedia, known as the Etymologies. He wrote this in the 7th century. So what you're about to read is common knowledge in the 7th century, because Isidore's encyclopedia was really the encyclopedia of the medieval age. It would be in every library that you went to. So as you can see, it's called The Inventors of Geometry, and its name. It is said that the discipline of geometry was first discovered by the Egyptians because when the River Nile flooded and everyone's possessions were covered in mud, the onset of dividing the earth by means of lines and measures gave a name to the skill. And thereupon, when it was greatly perfected by the acumen of wise men, the expanses of sea, sky, and air were measured. Stimulated by their zeal, these sages began, after they had measured the land, to inquire about the region of the sky, as to how far the moon is from the earth, and even the sun from the moon, and how great a distance there is to the pinnacle of the heavens. And so, using reasoning capable of being tested and proved, they determined the distances of the vault of heaven and the perimeter of the earth in terms of the number of stadia. But because the discipline began with measuring the earth, it retained its name from its origin, for geometry, geometria, takes its name from earth and measure. So this idea of the measuring of the perimeter of the earth is something that goes back a long way. And this is Isidore of Seville really quoting people from the ancient world. So he's looking back to the ancient world and bringing this knowledge into his particular age in the 7th century. As the images were suggesting, this is the size relationship between the Earth and the Moon. Now, if you want to put numbers to that, it's virtually identical to 11 to 3. So if the radius, or the diameter rather, of Earth is 11, the diameter of the Moon is 3. Now, as you can see, these have now been put into squares. So you can now say that there's a square with an edge of 11 and a square with an edge of 3, the Earth square and the Moon square. Now, in goes the pyramid triangle. And we can say it's a pyramid triangle because its baseline is 11, same as the square base, and its height is 7. So half of 11, 5.5, and half of 3, 1.5 equals 7. Now, the next thing that's going to go in is a circle which has a radius of 7. So as you can see, it's going to go through the peak of the pyramid triangle. Oh, actually, of course, before I say that, just to remind you that this is within, this is the cross-section of this type of pyramid, that is the Great Pyramid in Egypt. Now, the other thing to point out is that if you take these numbers 11 and 7, so base of 11, height of 7, and you multiply them both by 40, then you get a number of Egyptian royal cubits that are in the base and the height of the Great Pyramid. And we know what an Egyptian royal cubit is because there are various measurement rods in museums, such as the Louvre. Right, now I'm going to put in the circle with a radius of 7. Now this brings about what's known as a squaring of the circle. Now the squaring of the circle is where you have a square and a circle, or you could say a square perhaps derived from a circle that has the same peripheral measurement. And we can say that in this particular instance because we know that the circle with a radius of 7 has a circumference of 44. And so if we think about a square with an edge of 11, then that is also going to have, well, 4 edges. 4 times 11 is 44. Now, if we use pure pi, then it doesn't end up being 44. It's an incommensurable number. So in a certain sense, by rationalizing, by using 22 divided by 7, which is a rational approximation of pi, that is what brings about this, I suppose, coherence or relationship between the circle and the square. The square is as rational as can be. It's just 1 by 1, or 11 by 11 by 11 by 11, as we're looking at it here. Whereas the circle, properly speaking, is based on pi. But if we use a rational version of pi, then there can be this reconciliation between the incommensurable circle, the heavenly circle, and the rational earthly square. Now, back to this image from Hildegard of Bingen. The reason why I've returned to this is because it has interesting dimensions to it, bearing in mind that it also has these numbers associated with the diagram that we're looking at. If one was to say that the height of the image is 7, then the shorter edge, the baseline, is 5.5. Now, of course, 5.5 is half of 11. So if we imagine that we have 5.5 here, plus another 5.5 here, then we'd have the height of 7 of the pyramid triangle. So then we can say that the diagonal of this rectangle is the slanting edge of the pyramid triangle. Now, another way of looking at this is to look at it as having, well, you could say a pyramid rhombus. So imagine if you have a pyramid triangle pointing up and then a pyramid triangle pointing down, and those two triangles are joined at their bases. And then that is what you would have fitting inside this rectangle. Now I'll fade in an image to show you, I'll show you an image of Jean-Michel's diagram again, and you can see what I mean. So if you look at the 3 corners of the pyramid triangle, you can see that they coincide with the top and the 2 sides. And if you had an upside down pyramid triangle, that would take you down to the base of the image. So Hildegard's image, as well as using the numbers of the pi circle, they seem to be showing the dimensions of this particular diagram as well. And there you have it with the circle with the radius of 7, giving us the circle of 44. Now, Jean-Michel also pointed out a very interesting feature of the diagram, which is, as you can see, there are these 3, 4, 5 triangles that naturally also fit on either side of the moon circle. Now, this is of interest numerically because 3, the edge of 3 is by the moon, and the moon is always very much associated with the number 3. The number 4 is on the earthly square, and Earth is associated with the number 4. So this all works very harmoniously in terms of number symbolism. Now, the next stage of this diagram is to look at the mileage of these cosmological forms that we're looking at. Now, one of the key things really that Jean-Michel was very interested in is the idea that imperial measure isn't a human invention in the way that metric is. what Jean-Michel insisted upon is that imperial measurements are naturally existing units of measure. And when you use the English mile with this diagram, you can see why he came to that conclusion. So I'll go through those mileage measurements now. So all of these numbers that we're now about to look at, which are much bigger numbers, they're numbers of miles. Now, the mean radius of Earth is pretty much just very slightly off, I think something like 99.96%, 3,960 miles. And the radius of the moon is 1,080 miles. Now, if we add those two together, we get 5,040 miles. And the reason why we're looking at this is because the radius of the Earth plus the radius of the moon is what we're looking at. So it's this height of 7 here, which can be represented as being 5,040 miles. Now, 5,040 is a very important number for Plato, and it's talked about in Plato's final dialogue, which is known as the Laws, and it's looked upon as being a significant number in the sense of being an ideal number by which to order a society. Now, this is what he says about it. And now let us proceed to legislate with a view to perfecting the form and outline of our state. The number of our citizens shall be 5,040. This will be a convenient number. Let the whole number be first divided into 2 parts and then into 3. And the number is further capable of being divided into 4 or 5 parts, or any number of parts up to 10. The number 5,040 can be divided by exactly 59 divisors, and 10 of these proceed without interval from 1 to 10. Now, don't read all these numbers. I just do them just to really point out that there are, well, I've talked about them as being 60 because I've included 5,040 divided by 1 at the very beginning, which Plato doesn't include because it's not a division into parts. So as you can see, it's a very versatile number. Now, what we're going to see with another part of what Jean-Michel shows with this diagram is that there's this very direct relationship between the number 7 and the number 5,040, which both are used to represent the height of the pyramid triangle. Now, I'm just going to focus on the highlighted numbers, which are sort of on the right, slightly up. Now, what Jean-Michel showed is that if you do factorial counting, beginning from 1, 1 times 2 times 3 times 4 times 5 times 6 times 7, you get 5,040. But if you then begin from 7 and you go up to 10, 7 times 8 times 9 times 10, you also get 5,040. So within the decad, the first 10 numbers, which were of course the focus of the Pythagoreans, 7 has a sort of polar or mean position. Now let's look, for instance, if we have 6 as the polar number or 8 as the polar number before and after the calculation that we've just been looking at. 1 times 2 times 3 times 4 times 5 times 6, and stopping there at 6, we have 720 as our number, and then from 6 to 10, a much, much bigger number. So we don't have that mean quality between the two calculations. Now, if we go beyond 7 and we have 8 as the polar number, as you can see, it's the opposite way around. We first have the larger number and then the smaller number. Now, one thing I will say is that the number 720 is also very important within this whole diagram. And that's because when we talk about 11 units in terms of the baseline, or 7 units as the height of the pyramid triangle, 1 unit is 720 miles. Right, the last thing to show with the diagram, I've already shown you how the height to the base is 7 to 11 of the pyramid triangle. And if we look at that in terms of mileage, the height, as I've just shown you, is 5,040 miles. And the baseline, which of course is the same as the diameter of the Earth, is 7,920 miles. Right, so we'll take the first 11 numbers. And the reason for taking that is because within this count from 1, we include these two numbers, which are so significant within the pyramid triangle, 7 and 11. So we go from 1 up to 11. I've already shown you how the first 7 numbers, when multiplied together, give 5,040. So let's take those away, and we're just left with 8, 9, 10, and 11. And when we multiply them together as a consecutive calculation, you get 7,920. Now, I don't know about you, but to me, I think this is absolutely remarkable, but I cannot stress enough that this only works if you're using the mile as your unit of measure. So this is an example of why Jean-Michel felt very much that, that these imperial units of measure are naturally existing cosmic units. Now, of course, a mile is made up of a certain number of feet, and that brings it down to the human level. So if we're talking about the mile perhaps as a macrocosmic measure, then you could say that the foot is a microcosmic measure. And the idea that we've taken measure from our body perhaps needs to be looked at in a slightly or almost opposite way, in the sense that our bodies naturally but imperfectly resemble these cosmic units. Because if the foot comes from humans, which human did it come from? It's said to be a king, but if it's a king, which king? The king, as I've said, is really the microcosm, or the image of the microcosm, the human microcosm. And so in this sense, we can sort of say that there's a natural resemblance, because whose foot is actually the same size as an actual foot, not everyone's. Now, the other thing to say with feet, in fact, is there's 5,280 feet in a mile, and the relationship of 5,280 to 7,920 is 2 to 3. Very simple relationship. So here is the man. This is Jean-Michel. This is a photo that was given to me by Christine Rohn, who's a good friend of Jean-Michel's. And she said that she took this photo of him just after he'd been made into an honorary archdruid. And he has his Earth-Moon diagram in that sort of mirror glass around his neck. Now, I went on a pilgrimage to his grave because he lives quite, his grave is quite close to where I live in Wales. It's just down near Charmouth, that sort of area. 1933 to 2009. So as you can see, he died in his early 70s or mid 70s, I think. Now, of course, as you can imagine, I had to do an Earth-Moon diagram as an invocation to cosmic anamnesis, which really is what I think happened with Jean-Michel and this particular diagram. Now, the reason why I became so interested in this diagram is because I think it was about 1.5 years after he died. So back in 2010, I started to find this diagram seemingly used in the design of the first English Gothic Cathedral, which is in the city of Wales, where I live, where I've lived since 2005. Here is the ground plan. I was given a ground plan by a friend whose father used to be the treasurer of the Friends of the Cathedral. So I started just looking casually. And one of the things that came up at a very early stage, back in, like I say, back in 2010, was that if you look from the crossing, so where the transepts are, so I'll go back to this image. So this area here, the crossing and the chapter house, there's naturally a pyramid triangle that occurs between the center of the crossing, the center of the chapter house. And what I actually found first was a right angle triangle here, which is what can sometimes be called a Kepler triangle when it's in its golden ratio form. But when I put in the other right angle triangle going the other way, it took me to the threshold of the Lady Chapel. Now, the Lady Chapel, if you've seen my talk, Dante's Journey in Gothic Cathedral Design, you'll be aware that the Lady Chapel is this hugely significant place, which appears to symbolize Eden in the Far East, also the rising of the morning star in the East, also the thornless rose as an image of the Virgin Mary. There's all this Marian symbolism of the East and of resurrection. So we have these 3 points where we find the pyramid triangle. Now, after a while, after, I don't know, about a month, it suddenly struck me that, of course, I should look at John Michel's diagram because that's got the pyramid triangle in it. Now, as you can see, there's a bit of an uncanny lining up of the moon square with the octagonal chapter house. And so, of course, we have this apparent symbolism of an ascent from the earthly world, which is the choir down at the base of the pyramid triangle, up into the heavens, which is there symbolized by the moon, which, of course, is the first planetary sphere that one gets to as the ascent begins. Now, I wondered if this might be a random coincidence. So I started looking at various other cathedrals which had the same sort of layout. Now, one more thing just to say about this is that the choir is the same size and dimensions as the Temple of Solomon. I'll have to talk about that in another talk sometime because that comes in more with the golden ratio geometry. But just to say from the beginning that the Temple of Solomon in Christian terms is, of course, the central place on earth. And of course, it's a place associated with wisdom because of the wise King Solomon. So this is the beginning of the journey of ascent. This is the central place on earth, which of course the Temple of Solomon is in the Jewish tradition. Now, one of the cathedrals that I looked at first was Southall. It's a very small one up in Sherwood Forest, in fact. It has a very renowned chapter house with really quite remarkable green men in it. Now, I looked at it because, as you can see, it has a similar ground plan to Wells in the sense that it has this octagonal chapter house on the north side. Now, as you can see, the shading of the 2 halves of this cathedral are different. So you've got very dark shading here with the nave and the transept, and that's because that is earlier, that's Romanesque, so that's pre-Gothic. Now, the Gothic part of the cathedral, as you can see, is what's on the right, so where the choir and the chapter house are. The Gothic work actually begins from these 2 pillars here, and these are 3 arches which come off the crossing as the entrance to the choir. Here they are. So these 2 pillars that you can see between the arches, that's the 2 pillars that I was showing you on the ground plan. So this is the beginning of the Gothic work, which begins in around the 1230s. So if I put in the diagram, as you can see, the pyramid triangle fits very closely, going from the beginning of the Gothic work on the left and up to the center of the pyramid triangle. And down on the right, there was no Lady Chapel, I believe, because Southall Minster is actually dedicated to the Virgin Mary. So the whole cathedral is dedicated to the Virgin. So there wouldn't necessarily be a Lady Chapel for that reason. Now, again, we have this octagonal chapter house coinciding with the moon square. Now, in this particular instance, the octagon is fitting inside the earth square, because what I showed you with Wells is that the moon square fits inside the octagonal chapter house. Now let's move on to York. York is the other one that has this very similar layout of an octagonal chapter house on the north side. Now, I want to point out an idiosyncrasy that you can probably see there. If you look at that chapter house at York, it's got a slight skew in its orientation. It's not in alignment with the whole of the rest of the building. Even the vestibule that leads towards it is in alignment with the rest of the building. So the chapter house isn't. Now, why is the chapter house not in alignment? The worst theory that I've heard on this is that they just bodged it, which is always this crazy idea that comes up whenever there's any sort of irregularity in a cathedral. They're able to build a huge, very wide spanned vault above the choir, which is about 90 foot off the ground, but they just couldn't quite align that octagon on the ground. So this obviously leads us to say, why is it not in alignment? What is the reason for it? Now, the thing that became apparent, and bearing in mind that, again, we have the chapter house seemingly symbolizing the moon, is that there's actually a lunar angle at work here. Now, before I show you more of that, I just want to point out the Earth square in the diagram. The Earth square very neatly demarcates these 5 quite famous windows here, which are known as the 5 Sisters. They have geometric patterning inside them, which is known as grisaille. And there's this division of them into 3 and 2. Now, if we look down at the bottom end of the square, also the door has been incorporated into the square. So as you walk in through the south entrance, you're walking directly into this Earth square. Now, again, up here, we have a lady chapel. So rather like at Wells, this end of the pyramid triangle terminates in a lady chapel. So let's look at this skew of the chapter house. Now, the inclination of the moon is the difference between the orbital plane of moon around Earth in comparison to the orbital plane of Earth around the sun. So the horizontal line you're looking at there is the orbital plane of Earth around the sun. And as you may be aware, Earth is 23.4 degrees skewed from the axis, and that's how we have the seasons. Now, this is the same amount of skewage that you find with the York chapter house. You have this just over 5 degrees. So it appears to be this lunar angle. Now, the way in which this angle is discovered, it's known to have been discovered by Hipparchus back in the 2nd century BC. And it could have been discovered before that because there's no need for modern technology to find it. It's through looking at the nodes of the moon. And so this is where the eclipses happen. So this is how Hipparchus worked out this particular angle of the moon, by looking at where the eclipse happened in relation to where it had happened in that particular area previously. So he was able to take the older measurement and compare it with the one that he made and to say it was around 5 degrees. So this is old knowledge. Right, here we are back at Wells. This is a close-up of the Wells chapter house. Now take a look at the vestibule that's between the staircase and the actual octagonal chapter house itself. Now, as you can see, there's a skew there as well, and it is in fact the same amount of degrees as what the whole chapter house at York is skewed by. Now, here's looking up at the vault of that vestibule. This here is the apex of the arch that comes off the staircase, and this is the apex of the arch that goes into the octagonal part of the chapter house. So a very clear angular skew. And of course, again, you know, when you look at all the well-aligned work around you on the staircase and in the chapter house, the idea that it's just a mistake just doesn't really wash. It's very clearly an intentional thing. As an artist, I can say if you mark out something badly, you just do it again, because you can see that you've marked it out badly, and you just do it until you do it properly as you want it. Now, for quite a few years, because those skews that I've just shown you, I've been aware of them for quite a few years now, but for quite a few years, I'd assumed that that wasn't going on in Southall, because I couldn't see it. It's all straight and aligned there. But only just a few months ago, I sort of thought again, and this has been quite a feature of my research, that I have to not become too dogmatic about seeing something that it happens like that there, so this is what I need to look for elsewhere. And I worked out that I just needed to look in a slightly different way at what's going on at Southall. Here's the Southall chapter house. Now here is the doorway into the chapter house. You can see it's off center. This dark area here, this is the pillar between the two doorways into the chapter house. Here's an image of it. So you can see there's the doorway that's off center, and here's one seat on the same wall as the doorway. Now this is actually what creates the lunar angle. With these lines here, this line is giving us the east-west axis of the chapter house, as you can see, whereas this one is giving us the axis that's brought about by the off-centerness of that pillar. And it's 5.15 degrees. But the thing is, this actually happens via the fact that the pillar between the two doorways is at the golden section of the wall. It's actually a rational version of the golden ratio. I won't go into too much detail about the golden ratio. It's 13 feet for the wall, and then you have it divided up into 8 and 5. So by having the golden section, you have the lunar angle as well. And again, it's always around the doorway. So there is something about this movement through a doorway which leads you into this heavenly place, this octagonal chapter house, which in one sense is the moon, but in another sense also seems to be the 8th heaven as well. And this is why I think where I was talking about the nodes of the moon earlier. The nodes of the moon do also have this explanation in relation to the zodiac in terms of where they happen. And they're known as Rahu and Ketu in Vedic astrology, and they're known as shadow planets. So even though they're not actual planetary forms as such, they are relationships that can be seen through astronomical measure. It's actually where the moon's orbital plane crosses the Earth's orbital plane. That's what the nodes of the moon are. And that's, as I said earlier, that's where the eclipses take place. Now, the next lunar measure takes us back to Wells Cathedral. And this is that wonderful staircase, beautiful staircase that leads up to the chapter house. Now this, when you count the number of steps in this, it has a lunar number. In fact, it has two lunar numbers. Now let's look at the lunar cycles before we see how they show themselves on the staircase. Now the sidereal month is the amount of time it takes for the moon to go around the Earth once, and that's 27.32 days. Now the synodic cycle is what we see in the lunar phase, and that involves the sun as well as the Earth and the moon. And that takes 29.5 days or thereabouts. Now what I'm going to do is round these numbers up and down to their nearest, sort of easier fraction. And this is what the designer seems to do with the staircase. So 27.32 becomes 27.33333, which is 27.33, and 29.53 is rounded down to 29.5. Simple. Now let's take a look at the staircase. Here's the staircase going up to the chapter house. Here's a close-up of it. Now you can see there's this part step at the beginning. I'm going to focus on that first of all. Now this step is actually in the doorway, and so it's not a complete step, it's a part step. Now what I've done here, I've just taken an image of the bottom part of the staircase, which we're now going to look at in close-up. Now I know it does look like a shopping trolley, but you mustn't you've got to get that out of your mind, especially now I've just said it, so I shouldn't have said it. Now what we're looking at is the first few steps of the staircase. What I'm going to do is divide the first wide step, the first full step, into 12 equal parts. Now the reason for doing this is so I can show you some fractions. Now first there's 6/12, which is of course the same as 1/2. That's too big. So the doorway, or that first step, is not wide enough to be a half. Now if we go down to 4/12, which is the same as 1/3, that's too narrow to be the step. So as you can see, it's actually 5/12, and 5/12 is the arithmetic mean between 4/12 and 6/12. So by having the mean measure, it incorporates both a half and a third at the same time. So that's the way that we need to look at this first step in the staircase. It's both a half and a third. Now if we take a look at the whole staircase, the first full step is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Now 27 brings the curve of the staircase into a right angle, and it's the final step that features in both staircase routes, because you can either go up the staircase to the chapter house, or you can go up the staircase and carry on up this other staircase here. So 27 is a significant step in the staircase. Now, if you're going to the chapter house, after 27, you'd go another 2 steps, 28, 29, and then the next step is the vestibule itself. So you have 29 and 27, and you have the half and the third down here. So lunar measures going up to this vestibule with its lunar angle, going up to the lunar chapter house, according to John Michel's diagram. Now, as if that wasn't enough, there's actually another whole way of counting the staircase, which again relates to the moon. Now, this time it relates to something known, at least in this part of the world, as the Freemasons' magic square. Now, it has a very diverse reputation. Its oldest mention is in China, where it's known as the Lo Shu. There's a version of it in India known as the Kubera Kolam, which has similar but slightly different numbers, similar numerical relationships, but the numbers are different. It's also very significant in Islamic alchemy, and that seems to be the transmission point into Europe. It is written about by various Jewish and Muslim scholars in Spain in the 11th century. Now, the way in which it happens in the staircase is according to the various numbers that you can derive from the magic square. Now, the middle number, which is the arithmetic mean of the first 9 numbers, which is what the square consists of, the reason why I'm calling it the arithmetic mean is because its central position will always end up as the mean between the 2 numbers on either side. So for instance, if we say 1 is here, that's 4 less than 5, and 9 is 4 more than 5. And this just carries on, 3 is 2 less than 5, 7 is 5 more than 5, and so on. So 5 is this significant number in the center of the diagram, and you can arrange those 8 numbers around it in all sorts of different ways, but 5 will always be in the center. Now, what's known as the magic constant, and that's really what makes the magic square magic, as it were, and that is that whichever row of numbers or column of numbers or diagonal of 3 numbers that you count, it will always add up to 15. So that's the next significant number. Now, the total of all the numbers, which is essentially all the numbers from 1 to 9, is 45. So we'll also see that number as well. Now, there's a particular commentary on this magic square by the Islamic alchemist Jabir ibn Hayyan, who's known as Jebba in medieval Europe. It's thought to be possibly where the word gibberish comes from. That's one of these theories. I don't know how well that's known. But he talked about it in this way, where he highlighted the bottom 4 squares on the left, 3, 5, 8, and 1, and they add up to 17. And he talked about them as being the seed or being important in the essential basis of things. And then the remaining numbers in the green shaded area, he called gnomon, and they add up to 28. Now, a gnomon is associated with a set square. It's usually a right angle shape. It can be another more oblique angle as well. But the thing about a gnomon is that it's also something you can add on to a square to make it larger, to make it have a larger area. So in this case, if you have a square of 4 and you add on this gnomon, it makes it into a square which is 3 by 3. Now, these 5 numbers that we're looking at, these are the ones which all feature in the demarcated areas of the staircase. Now, just to remind you, the moon square is of course 3 by 3. So we actually have a 3 by 3 square close by. And the thing about this magic square is it's often associated with the planet Saturn, but it's also quite regularly associated with the moon by people such as Jabir ibn Hayyan and a group known as the Ikhwan al-Safa, the Brethren of Purity, who were a Pythagorean, an Islamic Pythagorean brethren in the golden era of Islam. So let's take a look at the numbers and how they occur. Now, the first 5 numbers, or the first 5 rather, relate to the first 5 steps. Now, there's no halves or thirds in the magic square. So I'm just going to count the first step, that shorter step. I'm just going to count that as the first step. Now, the first 5 steps are in a certain demarcated area with its own cross-ribbed vaulting. And as you can see, the stairs change and the window area begins once you get to the first 5 steps. Now, if we go another 12 steps beyond that, we of course get to the 17th step. And that takes place within, again, another bay area. So we have this rectangular bay with its own cross-ribbed vaulting. So that's another demarcated area. And that brings us to 17. And of course, it also brings us to the end of the rectangular steps and the beginning of these steps here, which are in the curve of the staircase, which are either wedge-shaped or L-shaped. Now, the next number that we go up to is 28. And this is that step I showed you earlier, which was the shape of a set square. Now, in the lunar count, this is the 27th step, because you'll remember the first step was counted as the half and the third. But in this magic square count, it's just the first step. So that means that the 28th step ends up being this one. And we actually have essentially the shape of a medieval set square with a sort of tapering arm. This is the way some of the set squares looked, and it was part of their measurement capacity, the fact that they had this tapering arm. So we have 28 associated with the gnomon of the square. Now, after this, because you'll remember 28 plus 17 equals the 45. So we have 17 steps left because there's 45 steps in all. Now, what I'm going to do is, because we need 15 rather than 17, the magic constant, you can see there's 2 more steps which take you up to the doorway on the staircase. Now, this is its own, I suppose, no man's land, or its own architectural zone, because it's outside of the green zone, but it hasn't gone through the doorway yet. Now, this is the doorway, as you can see, just up the staircase there. That's the zone that I'm talking about, this area here. So we have 2 steps there, and what that then allows is that the final staircase beyond the doorway is made up of the final 15 steps, and that gives us a total of 45. So you have apparently these magic square numbers that are often associated with the moon also in the staircase. Now, apart from that, and perhaps most importantly, the staircase is absolutely beautiful when you look at it. Right, just a few more things to show now. Here we have the pyramid triangles in the 3 cathedrals. Now, the other thing about this is that what I eventually worked out, about a year after I sort of saw this diagram according with what was going on, is that all 3 of these pyramid triangles have simple fractional relationships with the size of the Great Pyramid. And therefore, you could say the size of the Earth as well, because John Michel's diagram and the Great Pyramid both relate to the size of the Earth, or so it seems. So we have a direct relationship of these triangles with the size of the Great Pyramid. At Wells, it's specifically 1/5. So you can see the small triangle that I've marked off there. That would be the size of the triangle at Wells, whereas the whole triangle is the equivalent triangle in the Great Pyramid. So that's 1/5 of the baseline. Now at Southall, it's smaller, it's 1/6. And at York, which of course is much bigger, it's actually a golden ratio relationship. It's 1 to the square root of 5. This pyramid triangle can also be looked at as being in a golden ratio form. There's a golden ratio version, which is virtually identical to the 11/7 triangle. That'll have to be for another talk. Now, let's just take a skeptical position. Let's say that these pyramid triangles, they're not actually there in physical form. They're things which do line up, and when you actually start measuring in more detail, they do very clearly seem to be there. But because they're not actually materially existing, let's just take a very narrow-minded skeptical position and say, well, are they really there? Well, what I say to that is that there is actually one materially existing pyramid triangle in medieval Wales, but it would have been as hidden to the medieval human eye as these pyramid triangles are in the underlying design of the ground plans. Now, the reason for that is because you need to have satellite imagery or aviation technology to see it, because it's actually the arrangement of the walls of the Wells Bishop's Palace, which is just to the south of the cathedral. Now, the thing about these walls, they're arranged as a pyramid triangle, but also the length of them is the same as the height of the Great Pyramid. Here we have a simple ground plan. So if we say that this is the height of the Great Pyramid, 2000 or 280 cubits, if we were going to talk about the whole of the triangle, the same size as the Great Pyramid, what we'd need to do is to take this measurement. So if we put the point of our compasses there and the pencil here, and then we draw an arc like so, then we'd be able to give ourselves the whole pyramid triangle, or the size of it in the Great Pyramid. Now, before I do that, I just want to point out that this line, and it does very accurately, because I've measured it in situ, it very accurately brushes along the south wall of the palace building. Now, when you put in the whole pyramid triangle, as you can see, it gives you the other northern edge of the palace. Now, the other thing about this particular geometry is that that area where the palace is actually 60 cubits. You can mathematically calculate that it's 60 cubits. And that, again, is the same size as the choir in the cathedral, because 60 cubits is the length of the Temple of Solomon. Now, the other thing that I worked out is if you put an equivalent pyramid triangle going up to there, it goes all the way to the Lady Chapel in the cathedral. And I've done this on a satellite program. It's very accurate. And what you also have is the dimensions of the Earth and the Moon. If this here is the Moon, then the rest of both pyramid triangles is the Earth. So it correlates with all of the other things that we've been looking at so far. So there you go, lots of information this week, and I've made a few connections with what I talked about last week, but next week I'll go into, I suppose I'll start putting these 2 talks together, which I've already done a little bit of this week.